A dam is built on a local river to create a reservoir. The water level in feet of the reservoir Y at time X days since its construction is given by Y equals 3X plus 12. The first thing we want to do is find the X and Y intercepts. Then we're going to ask ourselves if these make sense within context. And then try to explain that if they do. And I mean, I guess if they don't make sense in context, we should try to explain it anyways. So let's look at part A. So to find the x-intercept, can someone remind me what should I do for the x-intercept? Yep. So for the x-intercept, you want to let y equal 0. So x-intercept, I'm going to write here, let y equals 0. So I have y equals 3x plus 12. I'm going to rewrite this as 0 equals 3x plus 12. What should I do first? Yeah, I need to isolate the 3x. So the first thing I should do is subtract 12 from both sides. And we end up with negative 12 is equal to 3x. And that 3 is really messy, so that's why I undid that. There we go. Now this 3 is being multiplied to the x, so the opposite of multiplication, being division, means we're going to divide both sides by 3. And this gives me negative 4 equals x. Okay. So before we examine whether this makes sense in context, let's go ahead and find the y-intercept. Then we'll deal with the context. So y-intercept, we already know that for the x-intercept, we let y equal 0. So for the y-intercept, we're going to let x equal 0. So I have y equals 3x plus 12. So y equals 3 times 0 plus 12. Well, this is easy. What's 3 times 0? 0. So I have y equals 12. Okay, so let's talk about these intercepts now. My x-intercept is, the x value is negative 4, so as an ordered pair, I'd write that as 4, 0. That's the x-intercept. And the y-intercept is an ordered pair is 0, 12. So to make it very clear, every time I refer to an ordered pair, I'm literally talking about a point x comma y on our graphing system. That is an ordered pair. Okay, so now let's talk about these in context. You know what would help us talk about these in context? Let's talk about a reasonable domain for this function. So y equals 3x plus 12. If this was not a real life context, this was just straight up algebra, what would we say the domain is? If there was no real life context. So I have a question for you guys, class, and don't worry, I am recording, but your voice will be cut out when I edit this. So my question to you guys is there any fractions we have to worry about or any roots? Okay, so if you don't have any fractions to worry about or any roots, and when I say fractions, I mean a fraction that has something with x's at the bottom. If you just had 1/2, that's nothing to worry about. And the same thing with radicals, I'm talking about x's within the radical. If you just had the square root of 7, you wouldn't have to worry about it. So we don't have any radicals with x's in them. We don't have any fractions with x's in the denominator. So if there was no real life context, then the domain would be from negative infinity to infinity. But now let's ask ourselves, before you write this down, let's ask ourselves the context. X represents what? The days since what? Construction. So does that mean, let's take a number in this domain, say negative 365. Doesn't make sense. Why doesn't x equal negative 365 make sense? Yeah, time only goes forward. The reservoir, this didn't exist. The dam didn't exist. Problem. Knowing that we can't go backwards in time, what is a reasonable domain? Where should we start? 0. So 0 to what? to infinity. Now, of course, time isn't going to go on forever, but we're not, we don't know. How about this? This dam is not going to last forever. We don't know when it's going to break, so I'm definitely going to say to infinity. Now, what about the 0? Do we include the 0th day? So, like, the day they finally cut the ribbon and the dam starts working, do we count that day? Yeah, we're going to count that. So this is our reasonable domain. Okay, so then let's talk about the x-intercept. So within this context, does the x-intercept make sense? So the x-intercept we found was -4, 0. Does that make sense in this context? You know what? Let me not even write it as an ordered pair. Let me just write x equals -4. Is -4 in this domain? Is -4 between 0 and infinity? No. So this -4 doesn't make sense within the context. There's no way to understand or think about how this function, how this dam would impact the water level before it was built, because it wouldn't impact the water level before it was built. If we're looking at the graph, I have a quick question. What is the y-intercept on this? Can someone tell me the y-intercept? We already figured it out. 12. And actually, you know what? Let's just go ahead and graph it, just to make it really clear. I'm going to go ahead and graph it, and this will give you more context as to what I'm looking for in graphs. So I'm just going to put a 12 here. And look, this is enough. This would be enough. Okay, there we go. And it goes, well, I have to make sure it goes through my y-intercept. There we go. Okay, so first question is, why did I not graph anything to the left of the y-axis? Because what? It's outside the domain, so I don't need it. Yep. And actually, I need to scale my x-axis too, so I need something on the x-axis. I'll get to that after our interpretation. So then at x equals 0, the number of days. So this is days since construction. Write this out a little better. Days since construction. And this is water level. And I think it's in feet. Yep, in feet. Okay, so what does that tell you? They were basically damming a river. So at 0 days, what was the water level of the river? 12 feet. That's what it tells you. If we go backwards to say here to -4, if we go backwards, was the water level suddenly 0? Did the water just magically come out of nowhere? No. So this is why it doesn't make sense. This x-intercept doesn't make sense within context. So it's outside of the domain, so it does not make sense. So let's write that here. Outside of domain. So it doesn't make sense. And since we're talking about what I would be looking for to make sure this graph was correct, when x equals 1, we would get y equals 15. So I would want to see something like that here. You can mark it on your graph. Let's say 1. And there you go. 15. All I want to see is that you have a scale on your x-axis and your y-axis. So I'm going to be looking for labels on both the x and the y. That's it. So that's not too bad. Okay. We'll still answer part B, but we're running out of space. So what I'm going to do is, just hide it real quick, and then we'll have to answer it somewhere else. So bear with me while I hide this. Okay, so we know the x value doesn't make sense in context. So this is the x value here. So this is the x value. Okay, now let's talk about the y. We'll talk about the y one right here. Okay, so what's a reasonable range for this? And this will give us a good opportunity on practicing finding the range without graphing, although I already graphed it for you. Let's hide, you know what? I'm going to hide the graph real fast so you guys can't answer with the graph, and then I'll put it back. You all have it written down. Okay, so let's pretend we didn't have the graph. How can I find the range? I need to look at my domain. What is my smallest possible input on my domain? What's the smallest possible value? 0. If you put a 0 into this equation, what do you get? For the y value. Yeah, if you put a 0 in here, we already did that. What do you get?
12.
You get 12. Okay, so I know it's definitely going to be a 12 in there. I don't know if it's the smallest or largest one yet, but I'll figure that out. So let me put a 12. Now, what if I put in a 10 for x? If I do 3, 10 plus 12, is it going to be bigger or smaller? Smaller than 12? It's going to be 30, it's going to be 42, it's going to be bigger. So does that mean we're going to infinity, or should I have a negative infinity in my range? Because this is bigger, right? So are we going towards the positive side or the negative side? Positive. We're going to the positive. So that tells me my range is from 12 to infinity. That's it. And now I'm going to go ahead and put that graph back that you all already have. There's the graph. I just wanted to kind of talk about how we could do the range without having a graph in front of us. Okay, so what do you guys think? Does the y-intercept make sense in context? Can we know something about the water level based on this y-intercept? What do we know about the water level based on this y-intercept here of 0, 12? What do we know? We chatted about it a little. Does someone want to help remind me? Does that mean the water level is 0 when 12 days have passed? No? Okay, so you're correct. It doesn't mean the water level is 0 when 12 days have passed. So what does it mean? The water level is what? 12 feet when how many days have passed? 0 days. So this one does make sense. So this one definitely does make sense in context. Let's write that down. So the water level is 12 feet when the dam is 0 days old, or is 0 days from construction. So in general, if you can explain it in a real life scenario, then it makes sense. So I'll write that right here. This does make sense. So this does make sense in context. All right, so let's talk about this last thing here. So this last question now. What is the slope? And what does the slope represent? So someone tell me, what is the slope? M equals what? What's the slope here? 3, yeah. And honestly, I can even rewrite this as a fraction. You don't have to rewrite it as a fraction, but it might make more sense if you think about it as a fraction. So I'll just write 3 over 1. So looking at it 3 over 1, and remembering that this is rise over run, what does the slope tell us in context? What do you think, Ben? What does it tell us? Okay, I like that. So it goes up 3 and then goes over 1. So that's our graph. It goes up 3 units, then over 1 unit. And when we go up, what's changing? Is the water level changing or the days changing? The water level is changing. So the water level goes up 3 feet every how many days? Every 1 day. So this tells us, the slope tells us that the water level rises 3 feet every day. You can also write it as this tells us that every day the water level rises 3 feet. Either way, the water level rises 3 feet per day. Okay, so hopefully this wasn't too bad, finding x-intercepts, y-intercepts, interpreting them in context, talking about domain and range in context. And we even got in some graphing, and we even talked about what I expect to see on your own graphs. I expect to see a labeled x-axis, a labeled y-axis. I expect these scales to be fairly consistent. I mean, I guess my scaling is technically really bad here, and I'll show you why. That should be more like down here. If this is 3 units, then and my x-axis should be really far down. So my scale is bad. My vertical scale is bad. I'm just going to say that. My vertical scale is bad on this one. But overall, I can read the graph. I can make sense of it. I guess if I really wanted to, I could just break this by doing a little squiggle here to show that I kind of cut off some of the vertical axis on the graph.